So our graph here that we are going to look at is titration of a stronger acid and a weak base again, but we are now titrating a weak base against hydrochloric acid. So it is pH curve for titration of a weak base against a stronger acid. The weak base we shall consider here is ammonia solution, which are writing as ammonia aqueous. It's not called ammonium hydroxide because that doesn't exist. The strong acid will be hydrochloric acid. So what do we have for this case? For this case, we shall have pH on the y-axis, small p, capital H. Draw your line for pH. Draw the x-axis. This word against here means what is in our conical flask?
Hydrochloric acid.
So in our conical flask, we have hydrochloric acid. So to the hydrochloric acid, we are against it. What is against it? It is the ammonia solution. So what is being added? We shall save volume of ammonia. Don't say ammonia just. If it is another base like ethylamine, don't say ethylamine just. You must add the word solution. Then also add the word added and put for us units in brackets. Are we together?
Yes, teacher.
Okay. Now, after knowing that, we must know that in the flask we have hydrochloric acid. Hydrochloric acid being a stronger acid, its pH must be very, very low. It's a stronger acid. So pH must be low. It must be around this point A, but not at 0. Then there should be a gradual increase. And then a sharp increase in pH. You will excuse my sketch here, but it should be sharp. Then there should be, I hope in your books you try to sketch it correctly. Then there is another gradual increase along there. This will be our point B. This will be our point C. Now, according to this reaction, no, this is the point B. The point B is here. The point C is here. And the point D is there. Now, according to our equation for this reaction, it is ammonia solution aqueous, ammonia aqueous, not ammonium hydroxide, reacting with hydrochloric acid solution to form ammonium chloride. This is a sort of a weak base and a stronger acid. So expect it to undergo cationic hydrolysis. Remember hydrolysis, form an acidic solution. This is the concept you must understand as you're sketching the graph. So we will form ammonia weak base and hydrogen ions. These ones make the solution acidic. So half of this distance B and C is where we shall have, I assume that's my half, that's where we shall have pH at end point. Draw a straight line, link it here. This should be your pH at end point. If that is pH at end point, look for the 7. pH at end point according to this is acidic. So it should be below 7. That means our 7 will be here. The moment you get that concept, you can sketch all the other graphs of any weak base and strong acid. So pH at end point will be at this point here. Then at 7, that's where we have what we call the equivalence point. Some people confuse the equivalence point and the end point. But I clearly stated to you in previous lessons the difference between the two. Let me hope everything is clear up to this point.
Yes, teacher.
Now, according to this graph, what do we initially have here? This is strictly that we strictly have hydrochloric acid. We haven't added anything yet. So pH there is due to hydrochloric acid. Along AB, what do we have? We still have an excess of the hydrochloric acid that has not been neutralized. Unneutralized hydrochloric acid is still present. Since we have added some ammonia solution, there is also some ammonium chloride that has been formed. Does this constitute a buffer? Does that constitute a buffer?
No.
It doesn't. So there we cannot talk of a buffer solution. I told you should be very careful. In this graph, there's always where we talk of a buffer solution. Now, along this region BC, there is the end point. So what we have there is only ammonium chloride and nothing else. Because the reaction is complete, end point has been reached. pH there, we shall say pH at end point is due to that, as we shall see later. Then along CD, what do we have there? We have now the ammonium chloride that was formed, plus the excess ammonia solution that is being added. Does that form a buffer solution?
Yes, teacher.
So that's where we shall talk of the buffer solution as we are explaining. The moment you get those concepts, you don't need to write these on your sketches, but you need to know what happens. The moment you get those concepts, then the explanation is going to become very, very easy for you. Now let's tackle the explanation. We need to clean this. It was just to explain the concept and then talk of our explanation here. So what are we going to say? We shall say at A, pH is very low due to strong, completely ionized hydrochloric acid that forms very many hydrogen ions. Are we together?
Yes, teacher.
Along, by the way, Muhammad is still present.
Yes, teacher.
Along AB, what happens, Muhammad?
The pH gradually increases.
Gradually increases as
The volume of ammonia, as far as ammonia is added.
As ammonia solution is added. As ammonia solution is added because there is still an excess of unneutralized hydrochloric acid. That excess unneutralized hydrochloric acid is the one that is bringing that gradual increase in pH. But also as some of the hydrochloric acid is being neutralized. There are two reasons basically there. By ammonia solution. Are we together? Along BC, what is happening? pH along BC sharply increases. Even, it's a very important statement, even with a little volume or a small volume of ammonia solution, added. Why is that so? This is because neutralization is complete over endpoint is reached. Point is reached. So as I've already told you, we divide our curves into regions to talk about. We talk about A, talk about AB, talk about BC, talk about the endpoint, where is it and why, talk about CD. So we have finished A, AB, we have finished BC. Let's talk about pH at endpoint. So pH at endpoint, by the way, here you must write the equation for the complete reaction. You must write that equation. I'm not writing it because I'm sure you know how to write it. If you don't know, if I'm to remind you, it's that equation between ammonia, not ammonium hydroxide, with hydrochloric acid, form ammonium chloride. Aqueous. pH at endpoint, we come back here, is slightly, where is it? Slightly above, below 7.
Below 7.
Slightly below 7. Why? Because
The salt formed undergoes cationic hydrolysis, producing hydrogen ion.
I will not accept when you say the salt formed, Muhammad. You must name that salt.
Okay, so ammonium chloride.
Yes, because the ammonium chloride formed undergoes hydrolysis to do what? To form an acidic solution, or hydrogen ions that make the solution acidic. Then you write the equation to show that. Which equation is that? Simplify your work, write ammonium ions. They are undergoing hydrolysis to give us ammonia and hydrogen ions. So we come to our last part of the graph. On our last part of the graph, what do we have? That is along CD. So what happens along CD? pH still gradually increases. I summarized the reasons here. The gradual increase there is due to that, because the excess ammonia solution added together with ammonium chloride, I'm writing the formula, you write the name, formed constitute a buffer. And in this case, this is what we call a basic buffer, a buffer solution which resists increase in pH. Are we together?
Yes, teacher.
Some people will say it is due to the excess ammonia solution added there. No. The reason is because due to that excess ammonia solution being added and the ammonium chloride that was formed constitute a buffer which resists an increase in pH. Now, the reasoning here is that I've always told you that whenever you titrate a weak base and a strong acid, you must talk of a buffer somewhere in your graph. When you titrate a weak acid and a stronger base, you must also talk of a buffer somewhere on your graph, because like it or not, a buffer solution must be formed. Are we together?
Yes, teacher.
Where shall we have the marks? We shall have the marks for this and for this. The sketch here will give you a mark such that the whole graph is 0 to 2 marks. When you come here, pH is very low due to completely ionized. The acid is strong and completely ionized, giving us very many hydrogen ions. That statement is half a mark. pH is gradually decreasing. As ammonia solution is added, that whole statement will give you half a mark if you give it as a whole. The reason there's still an excess of unneutralized hydrochloric acid, as some of the hydrochloric acid being neutralized by ammonia, that whole I will give it a mark. pH is sharply increasing along BC, even with a little volume of ammonia solution added. That whole statement is half a mark. Neutralization is complete and the point is reached. pH at end point is slightly above 7. That's the trend. What is the reason? Ammonium chloride undergoes hydrolysis to form an acidic solution. This equation may be given a mark, it may not. pH gradually increases along CD, Y. This whole statement here will give you half a mark. You end up having your 1, 2, 3, 4, 5 marks. If everything is clear, I wish to end this at this. Make revision about all these pH curves and practice them. You have a lot of questions which involve graph plotting. Plot those graphs, explain them. In our next lesson, I'll be introducing you to solubility equilibria, where we shall look up about things like KSP and so on. Thank you for attending the lesson. We meet next time. This lesson is going to be posted to our YouTube channel. Please subscribe to it for more of these.
Okay.
Have next time.
Thank you, teacher.
Welcome.